Okay, so this is just, I think my interface might be a little different than the one in his video, so maybe yours is as well. Anyway, the idea is that you just click on one of these nodes. The idea is that you're going to do the entire set of steps that you would do with the Explorer, You do it here, but you kind of make a picture of the whole set of steps, and then you can run it. So some people like to work with this kind of interface, and it might be good to show something like this in your final report, probably the updatable performance data stream that he shows at the end of this video. So here I'll just build the same one again. So you need a data source. By the way, data sync, I guess, means that you can save your results to your desktop in different ways using these, but right now we're not going to use that. But you have a data source, so you can load CSV files with this. You can load ARFF files with this. So in the example, he loads the ARFF, that file. So, and then he uses a class assigner next, which is here. And then he connects them using, you right click on it and you do this, and then you click on here. So you're assigning it as a data set. And the next is class validation fold maker. Class validation fold maker. And also use dataset to connect them. You just click here and click anywhere here. And the next one is the actual J48. So knowing the order of these, I don't know. I'm just following his model. So class validation fold maker, J48. Under classifiers, J48. And that gets connected. We want to get a split to a train and a test set separately. So we do training set and testing set. And classifier performance evaluator is classifier performance evaluator is here. And connect that also. Sorry, that one is connected with batch classifier. And then a text viewer. And connect that with text. And then he can run this. Now, he does it here, but that menu item isn't here. But you can do it up here. So you can click up here. And I guess if I do this, it's probably going to run both of them. But, I have to load in some data here. So here, actually, it's a little different than on his. But you choose configure. And you go to here and you can browse. So maybe I'll use a different data set. See if this works. Let's try the, I guess the contact lenses. Click OK. Now I guess this is going to run both of them, but let's see. Okay, so it's finished. And now we can check here. So look at the text, I guess. No, sorry. So if this happens, just click anywhere. It disappears. Anywhere except for on another node. So I think it's this one, show results. Okay, so there, now we can see the results. And he also makes a visualizer like this. He uses this model performance chart. So that doesn't get connected to here, that gets connected to here. So we can view things about the results here in this form, or we can view them guess this is this what he did? I'm not sure actually. I think he did visualizable error. So we try that. Okay, and then we run it again. That's finished. And then we can look at this. Show chart. So this is the chart that we've seen before. So you can build up this knowledge flow interface, and then you can save it and run it again later. So this may be a way that you like to work. I don't know how much documentation there is. You might find it on the web about how to use it. There are some other buttons up here, and there's some menus here. So one of these is undo. Another one of these is add a note. Snap to grid. New layout. Let's try that. Okay. And there is also load a template. So you have cross-validation, learn and save a model, ROC curves for two classifiers, learn and evaluate naive Bayes incrementally, compare two clusterers, two attribute selection schemes, save various charts to files, visualize prediction boundaries. We've done that, by the way. And parameterizing a job. So let's try this one. So it's just already set up for us. So it says this is already configured to run out of the box. If you want to add your own data, you click here and go to configure. So it's already set with the iris, but you can change that. If you want to specify the class attribute, double click on here, and here it's set to last, which is the species in the iris dataset, but you can change it here. If you want to change the number of folds, you can do that here in the cross-validation fold maker. And here, right-click and select Show Chart to see the scatter plot and misclassified points and performance results. Okay, let's try and run this. Okay, it's done. So with this, again, we can show the chart, or can show the results here. Okay, he also in the video does something with updatable classes, and in your final project I'd like you to show one of those. Okay, let's also explore the experimenter. This I feel is very important. So you begin by clicking New, and here the reason I think this is important is what you can do is you can add, of course, you can add your data set. So I'll just add something that's already here. Okay. Actually, let me show you what let me go to here and open that same data set. Actually, I'll open this data set, the glass data set. So, okay, so now what you could do, for example, is you could take, perhaps remove one of these, for example. And you could save this as glass minus, I forget what I removed, but minus something. I don't know what it was. Okay, so I have a new data set there, which has one less variable in it. Now let me undo that so I go back to the original one. And then I can also do something like, these are numeric. Maybe I could make one or some of these discrete. So I could go to filters and attributes, discretize. Okay. Let's see if this works. Okay, so now they're all nominal, and we've done stuff like this. Now I could save this data set, or I could have just made some of them discrete. This is called glass. I think I made them all discrete. Okay, so these are just some examples. And you could also create new variables. Now, to be honest, I'm not sure how to do that in Weka, but we did talk about deriving new variables. It could be, but I don't think it is, math expression. I'm not sure how exactly to do that. You might look around and try and figure out how to do it in Weka. But anyway, let's go back to the other interface, which is here. So now, actually, let me get rid of this because I changed the data set. So let's delete this one, and let's go to here. And we started with glass, and then we can add another one, which was, is it still here? Okay, they don't seem to be there, so let me try and do it again. So I'll save this one on my desktop. For some reason it didn't appear in the folder. And then let me go back, undo this, and then get rid of one of these. So I think I'll get rid of this, so that everything is numeric because I just undid it. So now I will delete this one, remove it, and then save this as glass minus, okay, and put that here. Okay, now let's go back to here, and there we've got the glass in there. You can also go to here, and you can add in this data set, and then you can add in this data set. Okay, so now we have different forms of the data set. So they have different features, or attributes, they have different forms of the attributes, and so on. So now you can add in different classifiers. So you can use this one, and you can try J48. Now remember that some classifiers only work with numeric data, and some work only with categorical or discrete data. So you have to be careful of that. But we can add in different, let's go to Bayes. And so you can compare many different data sets, many different forms of your data set with different attributes, and see which performs best, and also test over all the different, or many different algorithms. So once you've set this up, and he explains a bit about this number, so I won't go into that right now, but it's kind of for averaging the results. And this is basically also for averaging the results, but we can do kind of more averaging this way. So I'll just leave it as it is and go to Run and click Start. And it did all of them. And then you can see the results. So you have to click up here first. And then you decide what you want to see. So you can choose from any of these. So percent correct, percent incorrect. I think that's the overall accuracy, percent correct. And we can also do things like these rates that we've talked about. You can see those, and so on. So let's leave it as percent correct. And then you just click Perform Test. And we're going to see the results of using all the different forms of our data. We made only three right now, but you could come up with many different forms, and you could come up with and you could use many different algorithms. And not only that, but you could tune the algorithms, or you could tweak the algorithms. So you could use rule 0, but then you could tweak it in some way, or you could use J48, and then you could use a prune tree, and you could have different kinds of prune trees with different settings, and you could try them all together and see which one performs the best. So let's see what happens. Okay, so we get this. So this tells us compared to rules Z, this one was worse. Compared to rule, and you can see that, of course, this is rule 0, right? By the way, if you don't know what this is 1, and here's the key, rule 0. And this is 2, this is trees J48, and so on. So the V means that it performed worse. This one performed worse than this, not worse than this. And here, so here we can see actually, not too satisfying, but rule 0 did better than any of the others, which is kind of peculiar, but I guess that's the way it worked. And as he shows in the video, you can change this from dataset to algorithm. Well, actually, no, you could change dataset to these three, I guess, because this was columns. So currently the columns are here, but you could move these to rows, and you could move so you could move these to the rows, and you could move this to the columns. Or I guess you could just try swap. Okay, so let's try that and perform the test. And now we have the rules over here and the different data sets over here. You can see the actual names of the data sets. And now we can see, for example, that this one did better than this, which doesn't look right. I guess it's this one did better than these. Anyway, okay. Okay, and there are other things you can play with here, like the significance level, which you can see if you check here. So now we have the significance level. So to say what that means, remember when we chose we were going to do the test 10 times, and each test we won't get, this data is being selected randomly for testing and training, so we won't get the same results for each test. So we're running 10 tests here, and this is the average for the 10 tests, this 35.51. And so the mean of the 10 tests is here, but the standard deviation of the 10 tests is here. And so that's what using the show standard deviation does. And you can go back and listen to his explanation of some of this as well. So here we got 9 different results here, right? And we performed each one of these 10 times. So that's why here it says there were 900 results. But in your project, you would want to make many different versions of your data set and test many different algorithms, and then you can check to see which one performs the best. Then really, after you find which one performs the best, in order to report the accuracy of that, you would actually have wanted to taken your data set and split it up into 3 sets. Normally, we've been only talking about splitting it up into 2 sets, the training set and the test set, but you'd want to split it up into a further set, which I think they call the validation set, not cross-validation, that's something else, the validation set. So when you're testing so many models like this, some of them are kind of just by chance going to do better. So the idea is that you build the model with the training set, then you test all these different models on the test set, but then you want to take that the one that you choose, the best one, the one that turns out to be the best, and by the way, what would that be here? So it looks like here, 67.42, although a lot of variation in the results actually, right? So by the way, this means, for example, in this test, the performance was very bad, but when we tested, remember we tested 10 different repetitions of it. Sometimes we got one number, sometimes we got another, and they all averaged up to this number. But the numbers that we got in the 10 different tests were not too far apart. Like maybe some of them were +2, maybe some of them were +2 times 2, 2 plus 2, it's +4, but not much more than that. So you might have gotten numbers like 36, 34, 33, 37, but nothing too much further away from there. But here, this is 67, but this is +9, so that you might have gotten 76 or even +18. So these numbers varied a lot, and that's what this number means, that there was a lot of variation. So that means that we're not so confident that we're actually going to get 67. But anyway, going back to the notion of validation set, after you find the best, so here it looks like the best one is here. So that means using J48 and using the glass, not this glass, not this glass, but this glass. That gives us the best result. So then what you would do is then take the validation data set so you would have to sort of manually split this up into 3 sets, and then test this, J48, and this data set, and you'll get some result, and that would be the result that you should actually report as how well your algorithm does. So that is the idea of the validation set and dividing the data into 3 sets. So this part, using the experimenter, is going to be an important part of your final project. So please include this type of analysis.